you how to install and all those things. Okay, maybe let's give it a try. And it can be installed on Linux, Windows, and MacBook. So for Windows, it's just a executable, but you need to install the Windows subsystem for Linux to for the Linux containers to work. So first you need to install the WSL. It's a native tool within your Windows operating system, which is called Windows Subsystem for Linux. So WSL version 2 is where you will have the virtualization and all those features. So you can run the Docker desktop or the Docker application on the Windows. When it is running on Windows and MacBook, it is called Docker desktop. The same application, when it is running on Linux, we call it as Docker engine. Okay, that's a minor difference, because like it has the GUI and the graphics user interface is the major difference in Windows and MacBook. You have the Docker desktop with graphical user interface, whereas in your Linux you don't have graphical user interface. It's just a Docker daemon. It's just a Docker engine that will run on the Linux, which is in a way like more secure, more lightweight. It is definitely going to be very performance helpful and all those things. Whereas, okay, so this is also something it's good. And most of the production environment, it runs on Linux only. Only for learning and understanding the concepts better, you can use Windows or Mac. But ideally, you have to run it from the command, because there are very few commands. Okay, so I would say like 7 or 8 combination of attributes is what you generally use. You use Docker pull, Docker push, Docker compose, and only few commands you regularly use. So you can learn from Linux instead of going through the graphical method. Graphical method is always interesting, and for the initial 1 or 2 times, you can use the graphical options, install it on Windows and do it. But for the production support, for the production operations experience, you definitely need to run and manage and maintain on Linux platform. Okay, we'll see that. We'll see how to install it using the native application package manager. It can be apt or yum or maybe whatever the package manager for your operating system, RPM or different tools are there, right? You can use those tools and get things installed. And we'll also try and install it in one of our operating systems. So these are all instructions for your Ubuntu and Debian. So generally we do the update first to update the repository to fetch the latest packages and version. And once it is installed, you just directly go and install the Docker Community Edition and the CLI. See, Docker Community Edition is the server, is the daemon where exactly your actual containers run, and the CLI is where from you can manage it. You can have both of them in the same system, or you can install CLI on your local machine and container engine on the server side, and you can manage it from the local also. And yeah, so there are different package managers which you can use, like apt, RPM, DNF. There are many tools which you can use based on the OS, and you can install it. And I think for our AWS on Amazon Linux, you can use YUM, or you can also use the DNF command to install and manage it. Once it is installed, you can check whether it is installed, what is the version, and all those things. You can also use info command to check the version, the driver, the C group details, and so on. And you can run your first container and check it. So let's give it a try. Let's try to run it in one of our system and see how you can execute the basic command. And from there on, I will show you some of the advanced options, how you can create the Docker file, and from there on, how you can start running multiple layered application using Docker Compose and so on. So these are the common commands that you need to get familiar to start with. So this weekend, tomorrow, we will have more practical discussions. We will be able to see all these lifecycle commands: create, start, pass, stop, kill, remove. All those things we are going to see one by one and get familiar. We can also understand how to do the troubleshooting, how to check the logs, how to check the statistics. So all those things we are going to see in tomorrow's session, and including how to write the Docker file from the scratch. We are going to see it tomorrow. Okay, so for now, we are just done with only two of the topics, the virtualization versus container. I also gave some briefing on the how Docker is different from Kubernetes, and how Mirantis is providing Docker as a product. It's only the enterprise platform they provide, and Docker Swarm is a Mirantis product. If you want to use alternate product for Kubernetes, you can use Docker Swarm, which is a Mirantis product now. It was developed initially by Docker. So let's go into the installation. I have created one small VM on AWS platform. I just deployed it. I have not done anything. So you can create whatever OS you want. You want to install Windows or Ubuntu or Amazon Linux. It's up to you. You can install it and directly start running it. Okay, let me just connect. Any questions so far on the comparison, the basic things? Okay. Hope my audio is still clear, right?
Yes, Tim.
Okay. Okay. Just give me a minute. Let me take some water. So we'll close the session a little early today. The reason I need to step out, I will just install and show you a few things. And from again, I'll show the same thing tomorrow also. And I will also share how to install it on your Windows. I already have a video on that. You can just run it on your Windows laptop if in case you want to try it. Yeah, just a minute. Okay, let's install it. Um, Let me become an admin. Let me get the root privileges. So I mean, all the time, whenever you are trying to deploy some packages, you need to update the repository. So m update command or apt update or whatever package manager along with update, it's going to update the repositories where you are trying to connect and get the latest packages, right? So this is to update the repository. It will try to see whether it has access to all the needed necessary repository, or else it will try and update it. It will establish the secure connection to the package manager. So once this is updated, we will install the actual Docker. So it is connected to the live patch repository, and this is looking fine. So we don't have to do anything, and we can now install the package. So yum install. You can just directly say Docker, or if you want to add the hyphen y is to confirm. Yes or no question will be asked. If you're not adding this hyphen y, it will ask whether you want to install it, because you get an option to confirm whether you are installing the right package and all those things. So you can just say install hyphen y Docker, and directly it will go to the installation without asking for your yes or no confirmation. See, while installing the Docker, it also installs the underlying component, right? The runc, which is used for the controlling the executions runtime, and it also installs the container daemon. That's where the actual lifecycle management happens. The restart, the pass, the run, all those things happens using the container daemon, and the actual product is here, the Docker hyphen 25. This is the major version, and you have this other associated libraries. Ip tables is your Linux firewall, and there are quite a lot of other supporting things that got installed, as you could see here. So I just said install Docker, but then it identified the dependencies, and it also installed the other necessary, the container SC Linux, the secure enhanced Linux, and the library file that is needed, and the IP tables. And these are the two important things that is needed based on our architecture. Um, that's what we saw, right? This is the module one. And if you recall, so these are the two things that are needed underneath for your application to kind of function properly. I think it's here only. Okay, let me just zoom in. So these are the two additional things that got installed, runc and the container d. So it is needed irrespective of how you manage and maintain it, either as a separate single hardware each, or if you want to manage multiple hardwares together, you definitely need this runc and the container daemon. On top of that is where the Docker daemon works, because the runtime, sorry, the runc is the actual container runtime environment that actually helps you to create and start the container. So runc is the command that helps you to do that, and container D is where you manage the life cycle of it, where pulling the latest version, taking a snapshot, all those life cycle management activity happens using container daemon. Container, sorry, Docker D is where you actually run your container and handle all the API calls, volumes, network related activities, and so on. So there are three different tools, three different processes that work hand in hand to do the entire container management. Okay, so that is something you need to understand. That's the reason it has installed the other necessary packages to manage and maintain the lifecycle and runtime activities. Okay, so it's installed. So these are the complete packages that is now installed, and you can start checking the version and other things, and you can also check the runtime status, whether Docker is running or whatever, using the systemctl command. You might already know that. You can go and check the status of Docker here. So it will say whether it is running, or whether it is loaded, whether it is active or inactive or disabled. So by default, it has not started. So at the time of reboot, at the time of starting the OS, if you want to enable the Docker, you can enable the Docker at the time of running. It will start the service automatically. It has added a hyperlink. It has added a symbolic link to start the service at the time of machine start. And if you want to start the service now, you can just say start Docker after the systemctl command. Okay, that's it. So it will now start the service, and you can go and check the status again to see whether it is now active and running. So earlier it was inactive, it was dead, it was disabled. Now it is enabled, now it is active, now it is running, and you can see how much memory it is consuming, what is the process where the services are running now, and so all those details are available. See, behind the scene, it has also started some more backend daemons. So in order to take care of the lifetime other things, it will start the other necessary daemons also. So this is the one of the important daemon, you know, right? The container D. And also it has, it might have started, the runc might be already running, and you can see the API is now ready to listen. And through the Docker daemon, all the REST API call happens, all the pull image, push image, and all those activities, right? It happens here. And container D is managing the life cycle activities, like taking a snapshot, passing the container. So those kind of activities happens using. So these are all like hand in hand. You don't have to get too deep into it, but I'm just helping you to understand how this works. So now you have installed the Docker, and the service is now running. And if you want to again check only the version, you can also use some of the Docker hyphen version command, and it will give you the actual major build and the build version. Okay, so let me give you a few more. Okay, let's try some more stuffs here. So I'll show the Docker file tomorrow. I don't want to get it into that today itself. I will explain that in details. Okay, so we have installed, we have enabled, we have started running is. So you can just get the information. So this is another important command that you can generally use to get the complete information about the Docker here. So it will give you a lot of details, like behind how it is running, how things work, and what is the BuildX plugin that is available. So this is the product where you can use for building your images. It's like a developer tool that you can use. And similarly, you have no containers currently running, nothing is stopped, and you can also see the C group thing which I've already shared, right, through which only the resource sharing happens. So that is controlling the CPU, memory, and other resources that is needed for each and every container will be managed using the C group driver. And there are other plugins, and Docker is also already initialized. You can see what is the OS architecture, what is the operating system, kernel version, and you can also see where exactly the Docker's root directory is, where the library files are stored. Okay, so fine. Yeah, this is what currently you are able to see, and you can also try running some of the sample things. Okay, Hello World is a see any even in during a school college days itself, you might have learned about the very first sample thing that you generally run, right? You can also try that, so you will understand how the this is a default sample image. Okay, so currently if the image is there on the local hardware, local server, local instance, it will run it automatically. If the image is missing, for example, for the hello world, they need an image, right? And that image, if it is not in that, it will try to check locally, and then it will pull it from the library on the internet, from the Docker hub, and then it will pull it, and then only it will run it. So here it's a very small one. It's a quick image, and even most of the images that you see on the Docker hub, it's all small ones. And like, let's say I want to run a Ubuntu container. Okay, let's say I'm just trying this command just to show how you can download and how to get inside the bash mode. You can also do it. See, the hello world is a container image which has this content. Okay, this gives you a kind of very brief messaging about a little bit about Docker. Okay, so the Docker contacted the Docker daemon. It checked whether there is a local image. No, it did not have a image, so it pulled the image from the Docker hub, and then it ran the container using the image that was pulled from the Docker hub. Okay, so that's the kind of statement that it has provided using that image. So I'll just show you one more command here. So what this is going to do now is it will check whether there is a Ubuntu container available or Ubuntu image available locally. So I'm currently running this command on Amazon Linux EC2 instance. So it will not have the Ubuntu related OS files and all those things. So if your application needs, let's say, Ubuntu um, packages and all those things, see, for all the Linux, most of the Linux, right? So the name is different. So Debian, Alma Linux, or all these things. Only the product name is different. It all shares the same OS kernel. All the Linux, the kernel is the same. Through which it accesses the hardware, the mechanism is all completely the same. The OS kernel is always the same. Only the user layer or only the additional utilities packages is what is being added by different companies, SUSE or Red Hat or Ubuntu or any company. They just modify and add additional utilities on the user side of it. So again, I'm just running a command. So what it will do is it will go and check whether there is a local image for the Ubuntu operating system. And if it doesn't have it, it will go and pull it from the library of the images. I will show you right here, Docker Hub, or you can search Docker Hub or Docker registry. You can also type hub.docker.com. And if you go here, this is where it is pulling the official images if it is not finding the images locally on that system. See, whatever we currently ran, right? I can just show you. So Ubuntu is a image. So even though it's an operating system, it you can also have an operating system as well as an application like Nginx or Squid Proxy or Kafka or different things. You can also have an image with pre-packaged application also. If you want to do that, you can do it. See what it will do if you run the command Ubuntu alone. It will go and fetch the latest tagged image and it will pull it. But for example, if your application needs something a little bit older version, okay, so here are the tags actually. By default, whatever the latest version that they have, it will be always tagged as latest. So if I just say Ubuntu, it will always go and search and pull the latest image. But if you want to like, let's say, access a version which is older, or if you want to have something from the previous version, you can go and add the rolling version, or you can go and mention the specific tag or version number, and it can pull the oldest one also, right? So let's say here, okay, so they have these many version. So if I want to have specifically, let's say, 22 or 24 or 26 or 26, these are all OS versions. Like, let's say I want to install 24.04 version. Okay, what it will do is it will have a additional one particular indicator at the end, you can mention 24.04 and it can pull only that specific version. So if you are just entering docker pull Ubuntu command, it will just go and run the latest version, whatever is the latest here. Let's say 26.10 is the latest and it will pull that. But if you want to use something specifically using some tagging or some architecture or some specific version, you can go and add that particular number at the end and it can pull it. See, whatever we ran is the latest. Okay, latest is 26.04. It's not 26.10 in fact. So they are going and using n-1 to have a stable version. So if you are using rolling or noble or jammy also, it is all tagged using this number as well as a user friendly name. So by default, it pulls the latest, which means it is pulling the 26.04 version and it is running it here. So that's the thing you need to understand. Okay, so now I can just say docker ps and it will show me. Okay, we are in what the system only, right? Okay, okay, so we are inside the container here. So how it is different from earlier prompt here, you can just check the prompt was different here, right? See, earlier I was in the local EC2 instance. I was connected to the system with the IP address this. What has happened here is it is install the Ubuntu container as well as it opened a bash terminal within that container. You can see that currently I am in the let me just give it a try by saying if config, if the command works. Okay, no, I'll just give it an exit. You will understand the difference. See, currently I was connected to a container and on the bash prompt of that particular container here. So now I am just one step back and I exited and the running container will be visible using docker ps command. See, currently there is no running version. If I say images, there are two images it has fetched. One is the hello world image. That's the first command we ran. And we also ran a command called Ubuntu, which fetched the latest image as well here. So if you want to kind of pull something which is a little bit older, let's say I want to have 24.04 version, it will go and fetch the image which has that 24.04 tag and it will pull that. So you can check the digest number. You can also have uh, you can cross check that here. So if I go to this 24.04, it will have all those digest number and all those things. With that, you can cross check whether it has pulled the right image using the digest value that you see on the server. Okay, so this is some basic installation and how to basically pull an image and run it. So currently I've just tried to show you how to pull a couple of images. There should be a Docker image. Okay, again, we are inside the server now. I have to, sorry, inside the container now. I have to exit one level and then do it. See, because whenever you run the command docker run interactive mode, it will download the image as well as it will start connecting you to the container. If you want to just pull that image, use docker pull alone. Don't use the docker run command. Docker run command will download as well as run the container. It will do both the steps here. See, if you look at here, it has pulled the image and using the new image, it has connected your session into that hardware. So you can see that the container is connected and you were inside the container earlier and now you are back on the EC2 instance layer. So you can see that it has pulled 24.04 version as well as the latest version, which is 26.04, which was pulled a little bit earlier. Okay, and if you want to run it, you can again run the command. Now if I run docker run ubuntu this time, it will not go and fetch the image like it did earlier. Okay, so that one step will be skipped now. See, it has directly jumped inside the container directly now. Instead of going and downloading the image and all those things, it started running it because it found the image which is already available on the EC2 instance and it ran it as a container. Okay, so anyways, we'll continue more how to pull it, how to do packaging, how to create a Docker file. So all those aspects we will get to understand tomorrow. We'll get to have complete understanding on the Docker CLI commands, as well as we will get into the advanced mode of how to create a Docker file image and then manage and maintain the life cycle of the container. So we have just discussed only the first three portion of module one and I'll be here for 4 more minutes. If you have questions, you can stay back and ask it. If you don't have question, feel free to drop off. Thank you for joining today, and we'll catch up at usual time tomorrow.
Yes, then like you run the command for the to get into the container, right?
Hmm.
Um, that is Docker run hyphen Ubuntu, right? So after that, like you told, like it will be on the container level. To come out
Hmm.
of it, we need to run the pull complete.
Hmm.
What is it command? Is it the pull complete or what is the
No,
command?
Docker pull is
Stan?
the command to pull, just pull the image.
To come out of it, like you told, right?
Exit,
It
exit.
will be once we
I just ran a
exit. Okay,
exit
okay,
command and then I came out of the container. Okay, see,
okay,
just to be
okay.
clear, so Docker run, it execute two steps. It will pull the container image, and it will run the container, start the container image, and it will also make you to log in inside. So I also used one more switch here, hyphen IT. Hyphen I stands for interactive. It will
Yes.
make you interactively go into that container, number one, and also it will open a terminal. TTY is nothing but a pseudo terminal. TTY is a terminal in Linux. So there are two switches. So if you want to explicitly get into the shell, for example, I earlier I mentioned I want to get into the bash shell here. If I'm not mentioning the bash shell, it will default to the normal shell. Okay, so either if you want to have bash shell or sh, you can mention I want to get into sh and do that. See, I will just exit again. So let me run the command here. See, if I'm not using this bash, it will automatically default to the default shell. Or if I want to get into shell, I can also mention sh. So it will take to the normal shell instead of the bash shell. So there are two things: interactively enter into the container image, and also what kind of terminal you want, what kind of pseudo terminal you want. T means TTY, the terminal that you want to log in. And if you want to exit out, you can just directly exit it. Okay, so I think I just made a typo here. But yeah, if you just type that also, it will work without the bash also. It will default to the default bash terminal. See, if you look at the present working directory, you are in the root, or let's say if I want to just check the host name and stuff, you are in a different host here or container here. If I exit, now if I check the host name, I'm in the EC2 instance. Exit command is what takes you back to the host OS.
Yeah. Yes, sir. Like I thought, like you have given, we have installed two operating systems, right? Like the latest one and the legacy one,
Hmm.
right? Like, so
Yeah,
how to select? Like, if I wanted to choose if
tag.
something other than this as well, like,
Yeah, I mean, if you want to choose something else,
yeah,
you have to use the tag only. See, there are tagging that has been done for every version, right? So they have used user-friendly names also, and they also have the version number. You can use any of these things. You can use combination of both of them, or you can use a user-friendly name to select that particular tag. And using that tag is to identify a particular image or a particular version, or tag is the purpose is to identify, right? So you can identify and use that
yeah,
using the tag. It's there for multiple. See, for
okay,
example, there are a few more things which we will eventually discuss tomorrow. So there are very small version of Linux. I forgot the name of it. So think, what was that? So there are a very small Linux images that we have. Okay, so I will just show you the operating system. So as a developer, it's very easy to kind of use those one. It is less than 10 MB, 20 MB. Also, you will see Linux operating systems here. So you don't have to really have a very big one. There are very small size images also that are available. Okay, let me just check that. Smallest Linux image on Docker Hub. I think it was 7 MB or 8 MB size. Yeah, see the busy box is there, and there is one more,
okay,
Debian Alpine. Yeah, this is the one I was looking for. See, it's only 3 MB. The entire image itself is 3 MB only. So you get
yeah,
quite a lot of container application or operating system, which is very small in nature. So you can search for Alpine Linux, and you can also use that. You don't have to use what do you call Ubuntu or Debian or those things. You can also use very small Linux version based on the application need. Okay, so I have to step out. Okay, we'll
Okay.
continue with the question and answer also tomorrow. So tomorrow it's going to be practical session, and we will catch up. I'll stop the recording.